Okay, yeah, in this question, first of all, again I'm writing the equation for it is equal to I of infinity plus I of 0 minus I of infinity e raised to power minus t by tau, right? They ask you the value for I of t. For this we have to follow this formula, right? In the step number 1, we calculated at t equal to 0 minus, that is your steady state condition, right? In steady state, inductor always will work as a short circuit. In step number 2, we always calculate at t equal to infinity. Again, this is also steady state. Again, inductor will behave as a short circuit, and in both the cases we have to calculate inductor current. Okay, so this is at t equal to 0 minus, this would be IL0 and this would be IL of infinity, right? Step number 3, we calculate at t equal to 0 the transient condition when the switch is changed. So in this case, inductor will behave as a open circuit. Now where the inductor was connected, we always mark A and B terminal there. Okay, and from A and B terminal we need to calculate R equivalent, that is RAB, and transient we'll consider for the calculation of tau. Tau is the time constant. Understood? So let's move to the question. Hmm, hmm, hmm. Yeah, first I'm telling you, explaining you, then you can write it down. Okay, so in this question, first we'll draw it for at t equal to 0 minus, right? 0 minus is the steady state condition, right? And in steady state condition, I told you inductor will behave as a short circuit, right? Now tell me, at t equal to 0 minus, switch is opened or closed? T equal to 0 it was open, but at t equal to 0 minus it would be closed. Okay, now we have to calculate the current across inductor. Again, how many meshes are there? I1, I2 and I3, right? Now we can draw the three equation. Tell me the mesh 1 equation. Minus for I1, no, it is I1 only. This is the corner wall. Then hmm, hmm, hmm. Second mesh equation. Now the third mesh equation. So similarly we can get it, I3 value is 0, right? We are having two variable, two equation, we can solve it by calculator. Now IL would be equal to, tell me, I2 minus I3 or I3 minus I2? It would be, yeah, you can see they have always mentioned the direction of current. Yes, okay. I'm not solving, but after solving it you will get the value as 5 ampere. Okay, so IL0 will get it as 5 ampere. Clear? That was your step number 1. Next is step number 2, at t equal to infinity, right? So this is also the condition of steady state, and in steady state inductor will behave as a open circuit or short circuit. Open circuit, right? So this, if this is open circuit, then there is no source over here, correct? So if there is no source, then the current across inductor would be always 0 only, right? So we can simply write down IL infinity would be equal to 0, and this will behave as a short circuit. Clear? Now step number 3, we need to calculate at t equal to 0, that is your transient. I told you when your switch is changing, right? So at t equal to 0, tell me, it's going to be open circuit, so this is removed. Now I told you we'll always also need to remove inductor, right? So, and where the inductor was connected, we have to mark A terminal and B terminal, correct? This was 8 ohm, and yeah, 8 ohm, 48, 4 and 40, 4 and 40. Now you are standing at A position, you have to move to B. You have to tell me which resistance are in series and which resistance is in parallel. First of all, tell me, is there any current flowing through across 4 ohm? Like you are moving from A, okay. Can you go to the 4 ohm house? No, because you can't come back now. So there is no role of 4 ohm, okay. We can't take 4 ohm. Now see, this 40 ohm and 8 ohm are in series or in parallel? They are in the same path or at the different path? This 8 ohm and this 40 ohm are in the same path, so these are connected in series. So can we say that this would be 48 ohm and this is also 48 ohm, right? So now again you are standing at A, move to B. Tell me, this 48 and this 48 are in series or in parallel? They are in parallel, because you can't go through both the front at the same time now. So R equivalent, we got it as 48 parallel 48, that would be 24. Got it? Next we need to calculate tau. Tau is L by R equivalent. L is how much? L was, yeah, correct, 8. Okay, and R equivalent we got it as 24. So tau is how much? 1 by 3 seconds. We can simply put it in the equation, this equation, that is I infinity we got it as 0, right? I 0 we got it as 5. Again this is 0. E raised to power minus t by tau is e raised to power minus t by 1 by 3, right? So 1 by 3 goes up, so that would be e raised to power minus 3t. So simply we got it as IT is equal to 5 into e raised to power minus 3t ampere. Understood? Okay. Then After that, what they ask in the question, determine IL at t equal to 2 tau, right? So we can put it, we need to calculate I of t is equal to 5 into e raised to power minus 3, t is equal to 2 tau. We can put it 2 tau, right? Tau value we already know, that is 1 by 3, right? We calculated now. So if we'll put the value of tau, then that would be tau in 2 into 1 by 3, 3 cancel, 5 into e raised to power minus 2, right? And this you can solve it in the calculator. After solving it, you will get 0.68 ampere. Got it? And in the next part, what they said, hence calculate the energy stored in the inductor at t equal to 2 tau. Means we need to calculate energy. Tell me the formula for the energy stored in the inductor. Half Li square, half we know, L we know, I we already calculated at T2 tau, that is 0.68, right? Whole square. If we'll solve it, we'll get 1.83 joules. That is our final answer.